Hello, class. This will be the second of the recorded lectures for section 8.2. And this, again, is the continuation of solving linear equations using the matrix format and the elimination technique. And so the first lecture talked about how to convert equations into the matrix form and matrices back into the equation form. And so this section here will do the elimination calculations. So I pull up the PowerPoint here. And so with regards to these calculations, just like in the elimination, we have three things that we could do. You could interchange any rows. If you remember from section 8.1, we could interchange any equations, make equation 1, number 2, et cetera, same thing. And then replace a row by a non-zero multiple of that row. What does that mean? You could take any equation and multiply it by a non-zero number. And we showed you what we were doing with that. And then you could add two rows together and replace that row. And that's exactly what we did in the elimination technique when we had X's and Y's in there to be able to do those calculations. And then at the end, we'll end up with a matrix that could be solved, and we'll do some back substitution again. But now it's time to think about the matrix idea instead of manipulating the equations. So let's do a couple examples. And let's start with this example. Where is the equation? Let me, okay, find the equation. So this is the first equation that we're going to manipulate using these row operations. And the first thing you want to do is put it into the matrix format. And so this would be our original matrix. And remember, this we'll call row 1. This we'll call row 2. And those are equations 1 and equation 2. And again, we'll have X, Y, and we'll have the answer. So when we set this up, and for this calculation, we would have 1 minus 2, 2, and 3 minus 5, 9. So when we did the elimination technique, for example, if you look at this equation over here and you wanted to say eliminate the X variable from the bottom equation, right? We would multiply the top equation by minus 3, and then we would add those two equations together. And so when we talk about these row operations, we would use each one of these rows. So the thought would be is that you would take row 1, right, and multiply it by minus 3. And then what the next step will be is add it to row 2. And that's going to be our, and I'll call it N2, which is our new row 2. So we're going to replace that row. So let me walk through these in a step-by-step. So first step, we're going to multiply row 1 by 3. So when we do that, we get 1, whoops. Let's try again. Minus 3 times 1 is minus 3. Minus 3 times 2 is 6. And then minus 3 times 2 is minus 6. And then we'll take 3 minus 5 and 9. So the next step is we're going to do, and let's do that, say in green. The next step would be we're going to take minus 3R and add it to R2 and replace that with our new, right? So that's just like we're adding these equations together. So minus 3 and 3 is 0. 6 and minus 5 is 1. Minus 6 and 9 is 3. So that's our new R2. which would be our new equation 2 if we were doing it in with the values or with the variables x and y in it as well. And so our original R1 is 1 minus 2 and 2. So now look at this matrix. So what does it tell you? Well, what does the new R2 give us? Well, the new R2 gives us 0x. So that would be y equals 3. So you see we have y equals 3. So how do we get the x? Again, we do the back substitution. And you can see this is the original equation. And so that would be x minus 2 times 3. Plug in for y equals 2. So that would be x minus 6 equals 4. In this case, x equals 8. So when you solve for these, you would have x equals 8 and y equals 3. And so in the ordered pair form, that would be 3, 8. And you see if you plug these into here, you would see that that would also be a correct way of doing it. Typically, you'll just pick the top equation that you have up there when you do the back substitution. But a good way to check is to plug 3 and 8 back into the other equation that we started with and to make sure that works. Let's do that real quick. So, whoops. Let me try this again, rewind. X equals 3 and y equals 8. I had it backwards, sorry about that. So let's plug that in. So you would get 3 times 8 minus 5 times 3. And so that would be 24 minus 15, and that gives you 9. And you can see that that satisfies that equation as well. So this is the manipulation for two variables. Taking the equation and putting it into the what we call augmented matrix form and doing the same type of elimination. There are some fancy terms, and I do want to introduce one of them, and this is called the row echelon form. And this is that the entry in the row 1, column 1 is a 1, and all the 1s are 0. And it kind of sets it up where you could read the answer right off the matrix. And we're not going to spend a lot of time. Whoops, wrong button. Sorry. We're not going to spend a lot of time on this definition, but let me show you what we mean by this real quick here in the whiteboard. There we go, whiteboard. So let me clear this up. So row echelon. So say like we had a matrix that looked like this. So what it says is that the entry in row 1, column 1 is 1, and only zeros appear below. So let's do 3 equation 1. So that would be a 1 there, and then 2 zeros below. And the first non-zero entry in each row after that row 1 is 1, and only zeros appear below that. And so, for example, and then any row that contains all zeros is okay. So say like we had this set up, 0, 0, 0, 0, 0, 1, and say like we had 6, 7, and 5. So how would you do this? Well, this would be row 1, which is equation 1, equation 2, and equation 3. This would be x, y, and z. And this would be what? This would be our answer, right? So what does the first one say? X equals 6. Second one say y equals 7. And the third one says z equals 5. And so with regards to computer, you could just let the computer plow through all these numbers, and out will come an answer with regards to that. But a lot of the time, you'll just plow through the numbers and do the back substitution if you were, what would you call it? If you were a human being and not a computer. So what we'd like to do now is another example of the row operations, but with the three equation matrix. So I'm going to put it on pause here and grab that equation up on the whiteboard. Okay, so here is the three equations and three unknowns that we are going to solve using the augmented matrix and the row operations that we introduced in this section. And so the strategy will be, first, let's put it in our matrix format. And so if we do that, this would be 2, 2, 0, and 6. And this would be 1, 1, 1, and 1. And this would be 3, 4, -1, and 13. So we haven't done this operation yet. So that's why I wanted to do one where we're actually going to move the rows around. And you could see that if we want to get rid of, put a 1 at the top for x, and the other two x values be 0, it would be much easier to deal with the first equation here, which is 1, 1, 1, and 1. Because what we do is 1 times -2 and then add it, and then 1 times -3 and add it to the third one, and that would be good. So the first thing we're going to do is switch, let's call it R1 and R2. And so when we do that, it would look like this. 1, 1, 1, and 6, and 2, 2, 0, and whoops. Let me start over here. This should be a 1. Don't copy things wrong. And then this would be a 6. And then we'll leave this 3, 4, -1, and 13. So you see how we just flip those around. So this is R1, this is R2, and this is R3. Let me make sure that you can see that. Let me make sure we move that out of the way. Okay, so we switched R1 and R2. So now what we want to do is to make the 2 in row and the x in row 2 and the 3x in row 3 both to be 0. So what would be the strategy? Well, the strategy would be this. What we'll do is we'll take the current R1 and multiply it by -2, and then we'd add it to R2 and get a new R2. So typically what you'll do is you'll probably do this all in one step. And so that's what I'm going to do. So what we're going to do here is minus R1 times -2 would be -2, -2, -2, and -2. And so if we add it, -2 and +2 is 0. -2 and +2 is also 0, right? And -2 plus 0 is -2. And then -2 and 6 gives us 4. So this is our new R2, which is basically that new equation. And so what I'm going to do here is just erase this and put the new R2 in here, and I'll leave it in blue so we know that is new. So that would be 0, 0, -2. I lost my line there. And that would be 4. Whoops. So that would be a 1 and convert it back to blue. And that's our 4. There we go. I think you can see it better. Okay, so now we want to get rid of this 3 in row 3 and make it a 0. So what are we going to do? Well, here's the strategy. We want to take row 1 and multiply it by -3 and then add it to row 3. So it'd be -3 times row 1, and then you add it to R3, and that gives you the new R3. And so when we do that, again, we'll get -3, -3, -3, -3. And when we add it to the old row 3, this got to be 0. That's our strategy. -3 plus 4 is 1. And then -3 and -1 is -4. And then -3 and 13 gives us 10. So when we replace this with new row 2, it would be row 3, excuse me, 0, 1, -4, and 10. So there's our new row 3. So what do we have here? Well, that is our new matrix. And now you look at these and you say, ooh, we're almost done, right? Look, well, row 2 has z equals something, right? So that has one variable. And this bottom row has y and z, and our top row is x, y, z. So we're almost done. So if we do another switch, so we switch row 2 and row 3 now, what happens? So here's what it looks like. We still have 1, 1, 1, and 1 on top. And now we make 0, 1, -4, and 10. And then what we have on the bottom is 0, 0, -2, and 4. So this is almost in the row echelon form, where the key is that you have 1s on the diagonal and 0s anywhere underneath it. So to get it in the row echelon form, the last step we need to do is to do what? Take row 3 and do what with it? Multiply it by -1/2. And so if we do that, we have 1, 1, 1, and 1 again. 0, 1, -4, and 10. And if we divide that, it would be 0, 0, 1, and -2. So that is our row echelon form. You could have left it in this form and solved, and you would have got the same answer. But I want to make sure that, again, show you the row echelon is the diagonals here are 1, and anything below the diagonals are 0. So what does R3 indicate? Well, that would be the 0 column, or the Z column, excuse me. So Z would equal -2. Cool. What does our row 2 equal? Well, that would be Y -4Z equals 10. So to solve for that, you plug in -2 in for Z, and you get Y -4 times -2 equals 10. Y plus 8 equals 10. And so Y equals 2. So in this case, Y would equal 2. And so what does the row 1 indicate for us? Well, row 1 indicates X plus Y plus Z equals 1. And so if we back substitute the calculation we just did for Z and Y, we should be able to get X. So we get X, and what's Y? Y is 2. What's Z? -2, and that equals 1. So you see those cancel, and you get X equals 1. So these would be the answers. And you would have the answer of X equals 1, Y equals 2, and Z equals -2. So this shows you a more step-by-step approach where we actually switch rows around a little bit, which we haven't done before, and then put it into the row echelon form, which we've introduced. So you're probably asking yourself, why do I have to put it in this matrix form if I'm a human being and I want to do these calculations? Why can't I do it just like we did in section 8.1? And the answer is because we're trying to teach you how to think more like a computer. Because when you enter the data in the computer, you're going to enter it and the computer is going to put it into this matrix format. And so it really is the exact same operations, except what are we doing? We're making you think more like a computer than a human being, which is kind of tedious. I'm not going to lie to you. And if I do these calculations by hand, which I don't do anymore, but if I do, except when I teach, I would do them like we did in section 8.1. So you'll see that when you do this homework, it's going to ask you to do some of this matrix manipulation. So bear with it. So that ends this recorded lecture and lecture for section 8.2.